Hi, my name is Paras.
Hi, I'm Gopi Ravuri.
Shilpa Akula.
Swetha Gunamgari.
Hello, my name is Vishnu Nalluri. We are group 5 members. And today we are here to present artificial intelligence system for the class. Today we are here to present artificial intelligence system for the class Global Technology, year 2007, spring semester. Is it fall? I'm sorry, it's fall semester. Okay. I'm pretty sure so many people must have presented artificial intelligence, but here we are with something new in it. I hope so. So, artificial intelligence is a key technology in many of today's novel applications, ranging from banking systems that detect attempted credit card fraud to technology systems that understand speech to software systems that notice when you're having problems and offer appropriate advice. Well, these days most of the banking systems incorporate artificial intelligence, which if you use your credit card too often, and if you don't use your credit card for a while and suddenly there's a huge amount of withdrawal, artificial systems will block your credit card, which is done automatically. Next slide. Well, I have a definition for artificial intelligence. It says artificial intelligence can also be said as a branch of computer science in which design and implementation of intelligent agents are done. That's self-explanatory. It is a design process of intelligent computers that can act as a human with intelligent behavior. So here we are with roots of artificial intelligence. I found a couple of roots for artificial intelligence, starting from philosophy, logic, mathematics, computation, psychology, biology, and evolution. And I'm going to explain this to you as we go on. And there's two broad categories for artificial intelligence: is classicalism and connectionism. Classicalism is more like a rapid formulated mathematics. It does the calculations and we come up with an appropriate answer. Examples, practical applications would be chess, weather pattern. And connectionism would be more like human behavior, where you learn and you interact, which is mostly done by neural networks. And subfields of artificial intelligence, neural networks. Well, we have here brain modeling, this time series prediction classification. Evolutionary computation is more about genetic algorithms and genetic programming. It cannot be taught in a day. It has to be evolved in a series, or it should have pre-designed information in it to understand genetic algorithm. You cannot teach an artificial system just go about understanding genetic programming. It has to have a preset of information in its program. And we have vision, object recognition, image understanding. And the best practical example for vision would be DARPA. It's called DARPA. It's a US-based military program where the automobiles are run without anyone, and mostly it's fly-by-wire systems. So the vision system is very much in place right now. Okay, further we have robotics. Everybody knows about it. We have expert systems and speech recognition. Speech processing. Speech processing, I think Vista has a best speech processing in our operation systems, along with Dragon. And I also noticed that if you call somebody from T-Mobile or Verizon, a computer picks up the call and you need to speak to it, and it understands your language. That is mostly done by speech processing. Natural language processing, planning, these are further subfields. And I'm going to explain about machine learning later on. Elements of AI, machine learning, decision tree, problem solving, and knowledge representation. Okay, what is machine learning? Learning denotes change in the system that is adaptive in the sense that they enable the system to do the same task drawn from a population of similar, more effectively the next time. So it's all about learning and performing better. Types of learning, we have rote learning. It's like memorization, supervised learning. We have a set of rules, and unsupervised learning, that's automated learning. And this is rule indication system. It's self-explanatory. You create an initial set, then you have a training instance. You generate a new and old rules. You evaluate, and you filter the rules. If it's good, it'll finish. If it's not good, it'll take you to the second step. It's just a simple flowchart. Decision tree. This is really important in neural network. A decision tree is a tree structure plan of a set of attributes to test in order to predict the output. The to decide which attribute should be tested first, simply find the one with the highest information gain. Okay, here we have a simple logic thing. We have outlook. If it is sunny, we have 2 more questions. If it is rainy, we have 2 more questions. If it's overcast, that's optimized. You can go out. If it is sunny, then again humidity. If it's high humidity, you stay in. If it's normal, you go out. So in this way, you can actually predict whether you're gonna stay in or stay out depending on the weather information. Okay, here I'm handing over to Paras.
No, I can stay here and just.
No, you need to go there.
Basically, artificial intelligence is about that the complex problem will be solved by the intelligent machines, and I'm covering about the problem solving in artificial intelligence. So, what the problem solving is to achieve acceptable solution or a goal that we reach any goal with the use of artificial intelligent machines, and we should define the problem like the problem should be in a narrow, in focus, and clearly defined. And every problem should be represented by some knowledge to the system so that they can understand it. And so problem solution guided by knowledge and specific situation, and it depends on the situation also. And the example problem solutions are the winning move in the chess game, finding a route like finding the path, and placing the components in VLSI PCB. That's like a motherboard, and we can place the machines intelligently by the computer systems at the appropriate place. So there are around 6 steps of problem solving. Like one is the problem solving is the well-defined problem can be solved intelligently by the computer machines, and the problem should have the initial state. And initial state, that is, let's say this is a path that we need to reach from this to the this. This is the initial point, and this is the goal point, and so this is the initial state, and the state space is the whole diagram is the state space, and actions means to move from one node to another node. So moving is called action, and the goal test is that is the goal state has been reached or not, and the solution is the path from the initial to goal state. Like this is from this node to this one. So the computer system will automatically calculate which is the best path to go from the source to the destination. And there are 2 types of problem solving methods, like special purpose method and general purpose. Special purpose is very specific and for specific application only, and the general purpose is it can be used for many different systems. So basically the problem solving is done by the state space search. From here the search algorithm will start and find which is the best path to reach to the destination, and that is called the state space search. And states are used to represent the snapshots of a problem. Like any problem can be represented by using that kind of snapshot. And operators transform from state to state. So the main we call to move from this one to this node, and from this one to this one, we call it operator. And finally, the best path is selected. So the search techniques, there are many kinds of search techniques to go from initial to the destination. So one is the heuristic search. So it is search by learning. This is not the best, but it guarantees a solution. The sorting takes a little bit longer time, and this is useful for tough problems. And another 2 are the breadth first search, which is very easy to implement, and the nodes are accessed in order, like first this one, then this one, then this one, then this one, then this one. And in the depth for first search, it is also easy to implement, and the search starts from the root node and goes as far as possible before backtracking. So it's like search algorithms, like many of you have studied in the data structures also. So knowledge representation is what the machine needs to understand the language of the problem. So it should be the problem should be represented as a knowledge. So encoding knowledge so that machine can understand and solve the problem. Some form must be used to represent the knowledge, and the languages that are used to knowledge representation is first order logic, production rules, lambda, calculus, and Lisp. This is quite popular. And again, there are 3 steps in knowledge encoding. One is encoding, and the second one is the internet transformation process and decoding. So here are few branches of AI. That is, AI is used for problem solving, like in a chess game. Pattern recognition lies in biometrics, face and eyes detection, and learning and solving by neural networks. And we can use AI in strategy building according to non-facts. So now neural networks will be covered by Shilpa.
Thank you. The artificial intelligence, it's all applicable through application technology called neural networks. It's all about a method of computing based on the interaction of multiple connected processing elements. Here the elements are neural the neutrons. I mean, the neural network is nothing but it's an information process paradigm which has an inspiring build-up through biological neural systems and nervous systems like our brain. And next, the main where these neural networks can be used are like computing a known function that's like an algorithm functionality can be a resolved algorithms can be more effectively programmed using these neural networks and approximate an unknown function, a pattern recognition, picking up some structures from a recognized data, and signal processing. All the above processes, all the above strategies are learning. The learning of all the above strategies can also be done by neural networks. And the basic concept is a neural network is a mapping of inputs and getting the outputs from that. The basic biological terms, a neuron can be structured in a 3-dimensional component when you see through a microscopic components, whereas the neurons that are created by a man, the artificial neurons are not like that. They are basically structured as a clusters of primitive neurons, and those are like having some kind of input and getting the outputs from that according to the tasks they need. They are placed in kind of clusters and made it run through a kind of algorithms. The network itself is composed of arbitrary number of nodes. Those are the nodes, and the output nodes, they have a specific kind of topology built in, and the back propagated delta rule networks, it's the very supervised kind of a learning process. It's a layer by structured structured cluster of implementing the neural network. There are hidden layers in between, and the nodes are connected to the layers of outer layer and the inner layer, and it's called as a back propagated delta rule. It has an advantage of collecting the error details also, and propagating the results out of the errors, and making a filtering of the drawbacks it has, as Vishnu said, filtration process, and then go through the things and making the results up. And the artificial neural networks are the one which are made by a man. It's not natural. Those are like linked together according to the specific network architecture, and it has these are made to accomplish a certain kind of applications, like data recognition and pattern recognition. Those are the applications behind the neural networks. Next, the tasks majorly are covering like the controlling of movements of robots. That comes under the robotics, he told. The artificial intelligence application is through done by the neural network, artificial neural networks, and it makes the visual information and deciding the character of potential food items, like it is edible or non-edible, and recognizing a visual object, making recognition of a face or certain kind of objects. It's all the artificial intelligence implemented through the neural networks, and predicting where the moving objects, like sensing some kind of object which is in motion or which is on move. And the application parts are taken over by Swetha.
Thank you. Coming to the applications, neural networks has many wide variety of applications, like prediction, classification, and data association, data conceptualization, and planning, and many more. Coming to the prediction, like neural networks has a feature like it predicts what's going on. It learns from the past experience and put that experience in the future. Like for example, it predicts the weather, forecast the weather, identify people with cancer risk. Let's take an example of hospital, the emergency cases which are need to be given the priorities. It sets the priorities. Coming to the classification is one of the classification and image recognition is main applications of the neural networks. In classification, it recognizes image processing, predicts bankruptcy for credit card companies, and risk assessment. Like let's take an example of insurance company Nesta. In that company, the risk assessment. In that company, the risk will be evaluated. The financial risk evaluation is evaluated by the neural networks. Whether the given loan is good or bad will be evaluated by this. Next. Coming to pattern recognition, the main application is the Snoop, which is the bomb detector in many of the US airports. Snoop detects the bomb like by recognizing the chemical compound in that. Character recognition and handwriting, these mainly like are used in banks, financial services, and also in processing checks. Coming to the data association, it not only identifies the characters that were scanned, but identifies when the scanner is not working properly. Next, coming to the data conceptualization, it infers the grouping relationships. For example, it extracts the database, the names of those most likely to buy a particular product. And then coming to the data filtering, it smoothens the signal. For example, it takes the noise out of a telephone. And planning unknown environment sensor data is noisy, fairly new approach to planning. These are the main applications of the neural networks, and many more applications like marketing, evaluating the risk in financial services, etc. are done by neural networks. Coming to the benefits of neural networks, power, ease of use, and intuitively appealing. The power is nothing but it models a complex functions, non-linearity built into the network. Ease of use, very little user domain specific skills are needed for this neural networks. Everyone can operate that neural networks. Intuitively appealing, it's based on a model of biology that leads to a genuinely intelligent computer or robots. Neural networks cannot do anything that cannot be done using traditional computing techniques, but they can do some things which would otherwise be very difficult by the computer techniques. And also neural networks, it cannot by integrating the neural network with computer techniques, we can earn more profits comparing to the artificial intelligence. Thank you. Next.
Yeah, hi. I'll be explaining the benefits of artificial intelligence, as already my group mates have already explained the applications. They're useful in the banks, where every month banks need to calculate your interest and give you add your interest to your account. So that can be done artificially by artificial intelligence. Medical clinics can use artificial intelligence to organize bed schedules, make a staff rotation, and provide medical information. And financial institutions have long been using artificial intelligence to track people who didn't pay their bills and get them up and send their bills in order to get them paying their bills. Robots is another application of artificial intelligence. They often are given the jobs that are considered dangerous for humans. Robots have proven efficient in jobs like in doing repetitive jobs, which may lead to mistakes or accidents due to lapse in concentration, and other jobs which humans may find degrading. There are many robots have been increasing over the years, and Japan has the most leading number of robots, and General Motors use robots in painting and welding process in the industry. And some typical problems to which AI methods are applied: handwriting recognition, which was already explained by Swetha, where you can write on your PDAs and it transfers the data into digital data, and it can also format the data. Speech recognition and facial recognition are something related to biometrics, where a system can identify your speech or facial or your face to give you access to a particular system. Actually. And diagnosis is concerned with the development of algorithms and techniques that are able to determine whether the behavior of a system is correct. For example, these days Mercedes is using the diagnosis system, where they have a chip in the car and you connect a computer to the chip. It automatically tells you what the problems in the car are, and it can also be useful for the wheel balancing in cars, where it automatically tells you which wheel isn't in the right balance. Optimal mark recognition is the process of capturing data by contrasting reflectivity at predetermined positions on a page. By shining a beam of light onto the document, the scanner is able to detect a marked area because it reflects less light than an unmarked surface. An example for this is the feedback that we just filled out. It uses the optical mark recognition, where when you put it onto a scanner, it directly reflects on what on what feedback we have given Dr. Wahby. And I would like to say something that Dr. Day, who was a the guest speaker, he said that with you can change the screen just by looking at the presentation. I think that needs artificial intelligence. So you got to do something like this to change the screen. All right. Yeah. And the conclusion will be said by Vishnu.
All right, here we come to the concluding part. Have you already seen, we tried our best to explain artificial intelligence. So this is what we feel about artificial intelligence as a system. People, the very concept behind trying to understand artificial intelligence is to understand how humans work, how humans think, and their ability and their limits. That was the concept behind finding out more about artificial intelligence. But as it evolved at a stage, it became more scientific and technological field, affecting many aspects of our daily life. As you can see, 5 years down the line, probably a lot of your background stuff would be working on artificial intelligence. Next. So even as artificial intelligence become integrated into our everyday life, researchers remain focused on the grand challenge of automating intelligence. Well, the challenge always remains. People think the more we automate things, the better, because it reduces error. That is the goal of artificial intelligence, is to automate almost everything that we come across in our daily life. And the real practical application of artificial intelligence is still years away. Otherwise, we wouldn't be here with Dr. Wahby. Artificial intelligence system would be teaching us. And the much anticipated advances in knowledge and technology will require a sustained collaborative fundamental research effort. It doesn't need one person or two person. It's the way thinking must change to improve artificial intelligence. And that's all for today. And thank you very much for giving us this opportunity.